Today we're going to do 10.3 examples. Remember to look at your notes, and if you need to, watch the video of the guided notes on 10.3. So we're going to deal with inscribed angles and arcs today. Remember that the angle is inside, so this is our angle, and that the arc is talking about the section, curved section of the circle. Also remember when you hear the word inscribed that it's on the inside and circumscribed is going around the outside. So we have 4 theorems that we're going to work with that deal with the measures of inscribed angles and the angles of quadrilaterals. So the first one we're going to deal with is theorem 10.8, and it tells us that if an angle is inscribed in a circle, then the measure of the inscribed angle is half of the intercepted arc. So in this particular set of problems, the measure of the angle is going to equal half the measure of the arc. So it's pay attention to which piece is which measurement, and then it's just substitute into the equation and solve. So for the first problem, the variable x is the arc, and our 17 degrees is the angle. So when we fill in our formula, it's going to be 17 is going to equal half of the x. And now we solve. Remember to get rid of multiplication by a half. You can divide by a half or multiply by 2. And our x is going to be 34 degrees. In the next example, pay close attention to which pieces we're working with. So this 3x is our measure of the angle, and it is going to equal half of our arc measurement. The arc is this curved section, which is 138. So we're going to take half of 138. So if you need to, we get out a calculator and we have a half, or 0.5, times 138 to get 69 is equal to 3x. And when we divide by 3, our x is going to be 23 degrees. Be careful, the next one has a algebra expression for one of our measurements, so pay attention to what is what. So our angle measure is the box. Remember, that's 90 degrees. And this is equal to half of our arc measure, which this time the arc measure itself is an entire expression. Remember that this entire expression goes in parentheses. So we have our 4x plus 8. Now for our solving, we start by distributing. So 90 is equal to 2x plus 4. Subtract 4, and we get 86 is equal to 2x. Divide by 2, and our x is equal to 43 degrees. So our next example is going to use theorem 10.9. So in this particular problem, we're working with 2 inscribed angles, and they have the same arc, then they are congruent. So when we look, there are 2 inscribed angles. So we have the angle that has the 50, and we have the angle that has the x, and they have the same intercepted arc. So for this particular problem, those two values are congruent. So our 50 for the first angle will equal the x for the second angle. So in this problem, x is equal to 50. So we look at the next one. Pay attention to where the angles are measured. So we have the 80 degrees in the first angle measurement. We have the 3x plus 5 in the second measurement, and they have the same intercepted arc. So these two are congruent. They have equal measures. So we subtract the 5 and get that 75 is equal to 3x and divide by 3. And this x is 25 degrees. So we look at the next problem. So the 5x minus 2 is measuring the angle at the top left, and our 4x plus 9 is measuring the angle at the bottom left. And since they have the same intercepted arc, these two are going to be equal. So when we solve, we're going to subtract the 4x to get the x's, and we're going to add the 2 to get our constants on the same side. So this is going to be x equals 11 degrees. Our next question deals with theorem 1011. Notice that this particular theorem is an if and only if, so it works two ways. We can use this theorem to decide if our quadrilateral can be inscribed, and we can use this to find missing angle measures because opposite angles are supplementary. So in this one, we already have the inscribed. So for this particular set of problems, we're going to be using the fact that the opposite angles are supplementary. Remember from chapter 1 that supplementary means that we are going to be getting a sum equal to 180. So we have to pay attention to our opposites. So our y and 87 are a set of opposites, and our 2x and 100 are a set of opposites. So opposites will be across from each other in the diagonal. So we're going to set up two different problems, one for each set of opposites. So our 2x plus 100 will equal 180, and our y plus 87 will equal 180. So with the first equation, we subtract the 100, 2x is equal to 80, and divide by 2, x is equal to 40. For the next one, we're going to subtract 87, and y is going to equal 93. So pay attention to your opposites. So the next one are y plus 5 and 2y minus 3 are in opposite corners. And the 90-degree box and the 3x are in opposite corners of the quadrilateral. Since it is inscribed in our circle, then we get to do our supplementary. So our 3x plus 90 is going to be 180, and our 2y minus, should be a minus 3 plus our y plus 5 will equal 180. So for our x equation, we subtract the 90. 3x is equal to 180. Divide by 3, x is equal to 60. And for our other one, we combine like terms, so it's 3y plus 2 equals 180. Subtract the 2, 3y is going to equal 178, and divide by 3, and we will get 178 divided by 3 is 59, and 0.3 repeating is 1/3. Okay, so keep in mind that we are using our supplementary with each set of opposite angles, so we get 2 different calculations each time. So each problem uses each set of opposite angles are supplementary.